What is going on, guys? Welcome to your 34th Java tutorial. And in the last tutorial we built our init method, and in this tutorial, as promised, we're going to be building our draw method. So let's go ahead and just add a little comment that says draw, and it's going to be public. Actually, it's going to be synchronized and void. And of course, go ahead and name it draw and pass it in a graphics 2D parameter and go ahead and name that G. And now let's go ahead and get started. The first thing we need is the width of our screen, and we need to store it in a variable. And I'm going to store it in W because I don't have to type a width or anything. And it's going to be s.getWidth. So now W is equal to getWidth, and of course we're going to set one equal to H, which if you couldn't guess, it's s.getHeight right there. So now it saves us just from typing these. So now let's go ahead and utilize these babies. Now we're going to be doing a little math here, so watch out. We need to take and change the location of the image in both its x and y coordinates, depending on where it should be. So the first thing we need to do is we need to take image, and we'll work with our x coordinate first. And let me find my modulus. Modulus equals w. Now let me explain to you guys what this means. Remember, the image x is the x location of the image, and the w is the width of your screen. So what this says is this: if your image is, let me take it one step back before I even start explaining that. What this means is image x is equal to the remainder of image x divided by the width of your screen. So what this means is this: whenever you're working with modulus, if you do something like 700 divided by 1000, even though there's not really any remainder, it gives you 700, or that original value, as your answer. So if you did something like this, 1000 divided by 700, the modulus of that, of course in that case there's 300 left over, so that's your modulus. So what it says is this: if the location of image x is less than your screen, for example, if this was 700 and this is 1000, it's going to give you that remainder, which is just 700, which is pretty much basically what it needs to be. But if it's more than your screen, then it's going to give you how much it overlaps by. So for example, if this was like 1000 and this was 700, it's going to give you 300. So if you overlap by 5, it's going to be 5. Overlap by 15, it's going to be 15. So that's going to be able to, according to how much it overlaps by, that's how much you want to place it on your screen. And once you see this program run, it's going to make so much sense to you, but it's really hard to describe how images move around on your screen. But that's pretty much what's going on right now. So we need to do the same thing with the y value, of course, and set this equal to h. And now we just need a couple checks and balances. Now we always need the image location to be positive, and this is because if you try to place the points -5, -18 on your screen, those don't even exist on your screen. So what we need to do is kind of trick it into being where it needs to be. So image.x, if image.x is less than 0, then what do we want to do? We just want to take that same image and we want to add an entire width to it. So pretty much if you go negative on your screen, it's just going to change it into positive real quick and bring it over here. So it's going to actually be negative, but it's going to be the appearance, or we're going to trick our computer into thinking that it's positive. But the viewer is just going to view it in all one motion going off your screen. And again, this is another thing that you just need to look for. I mean, it's really hard to describe in words what's going on with this program, but once you see it run, again, it's just going to be pretty much a bunch of tiles moving around your screen indefinitely and not constrained to the screen size. So image.y is less than 0, and this again is just for the height instead of the width. What we want to do is take image.y and add an entire height to it. So if it's -10 and your screen's 1000, it would now be 990. There we go. So with all that crazy math, if you understand this, if you can understand this, then you can understand this entire tutorial. So now let's go ahead and do a few more confusing things. Let's just go ahead and take int x and set this equal to the location of image to x, because we're going to be doing a couple things here in a second. And int y, I think you're going to know what I'm going to be doing with this. Image.y. And now we need to draw 4 boxes on our screen. Now remember, we always see the positive thing on our screen, but what we're going to be drawing also is 3 negative boxes. So here's what I'm saying. We have a box right here, and this is pretty much going to be x and y. We also need to draw a box to the left of it, above that, and above that. So there's going to be 4 pictures drawn on our screen, and that's because, alright, when we take this image in the bottom right and we move it off the screen, then we don't just want the border around it to be white. We want it to show the image tiling as well. So that's what I'm trying to say. We're drawing tiles with this one, and we're going to be drawing 4 tiles, and that's going to give us our entire ability. So no matter where we scroll, even if we scroll our image off the screen, we still see the 3 other tiles. It looks like it's repeating. So let's go ahead and go g.draw image, and wow, that's a lot of parameters. We do not need all of those. And what do we want to draw? Well, in every case we want to draw the background, of course, and in the first case we want to draw x and y, and this is going to be our main box. And let's go ahead and copy this and paste it, and we should. Why are we getting an error? Oh, we don't have an image observer. No. And now we need to copy this 3 more times. So 1, 2, 3. And of course it can't just draw x and y the whole time, because this is the location of where it draws. We can't just have this, or else it would just draw 4 images on top of each other. So what we want to do is, we have our main box just chilling right here. We want to draw an image to the left of it. So how do we do this? All we do is we take x, which is location, and minus an entire width of our screen. And remember, width is equal to the width of the screen. So what this is going to do is draw a carbon copy of the image to the exact left of it. So now we need to draw one on top of our original. So here's our original right here, and if we take y minus height, it draws an exact background right to our right above our main image. So now how do we draw an image not only above it but to the left of it as well? Well, what we need to do in this case is x minus a width, which is going to shift it over one screen to the left, and also y minus a height, which is going to move it up, because remember, negative is up and negative is left on your screen, because the top left corner is 0, 0. So with that being said, what this is going to draw is 4 tiles side by side each other. So it's pretty much going to look like a tile here, a tile here, a tile here, and our main reference tile right here. So then no matter where you scroll on the screen, you can't escape seeing those other 4 tiles. So that is how we do that. I know it's confusing. The rest of the tutorial is a piece of cake, I promise. This is the only really math we have to deal with in this tutorial. But trust me, if you understood this tutorial, then you will be good to go. So thank you guys for watching. Don't forget to subscribe, and in the next tutorial, everything is going to start coming together and making sense. So again, don't forget to subscribe, and I'll see you next tutorial.